The origins of our universe can be traced back to a single point of infinite density. About 13.8 billion years ago, it started to expand. Scientists regard this event, and the explosion that caused it, as the Big Bang Theory. The early changes of this process, singularity, occurred amidst extreme heat and density as the fundamental forces of our universe began to form. Next, during epoch, the universe expanded rapidly and was filled with homogeneously high density. During cooling epoch, the universe decreased in density and temperature, and the fundamental forces of physics and elementary particles formed. These three stages happened within seconds. But if we simplify this, the first 3 minutes of the Big Bang was all about physics. Violent collisions underpinned the eloquent process of world building. And as the building blocks of our universe began to form, the core nucleus, atoms, and elements we recognize today came into existence. After nucleation, two of the first atoms we believe to form were helium and hydrogen. Hydrogen is recognizable as it has a simple atomic structure of one free electron orbiting around a single nucleus. This makes it easy to bind and present throughout organic and inorganic matter. Because of this, it's no surprise it makes up 90% of atoms in the universe. Helium, on the other hand, has two free electrons floating around a nucleus. It makes up about 24% of the universe's mass and is the most abundant element. Unlike hydrogen, it is the most stable element and rarely reacts with other elements. So what came after physics? Chemistry. Through chemistry, we saw the formation of rudimentary molecules and chemicals. If you imagine the cosmos as a grand orchestra, things eventually get more complex. Galaxies, stars, and planets formed, each playing a unique instrument in the symphony of space. The harmony of gravity, the melody of stellar winds, an exquisite composition that echoes through the eons. As part of the galaxy formation era, we saw the birth of early stars from giant clouds. The eventual death of these stars would give way to the heavy element, which would turn into new stars and planets, including our sun, which is 4.6 billion years old, and the solar system, which is 4.5 billion years old. So how does this end? Some feel that the universe will continue to expand until it can't, at which point we will see the whole process repeat, creating a new universe. So, where does this leave us? Fast forward billions of years, and here we are, on a pale blue dot, surrounded by a vast cosmic ocean. The universe is dynamic and ever-changing, evolving in ways that continue to astound astronomers and researchers worldwide. This means that we are locked into the universe's continued expansion, limited only by the telescopes astronomers use to take a peek into the past. Although life on Earth may be unwieldy and fast-paced, it is merely a side plot in a larger story about the universe's own creation and continuous expansion. What happens when it ends? Nobody knows.